Welcome to Study Life. In this session on SHM and waves, we are going to talk about harmonic motion and non-harmonic motion. What does it say? The very first thing about harmonic motion, I already discussed about it in the previous session, was it has to be periodic in nature. It has to be very much periodic in nature. What is the story with periodicity? Here we understand that my time period is fixed. It is constant. It is not changing. What is time period? The time required to complete one wave or one oscillation or one circular motion or any frame. The time required to complete this entire frame is called as time period. Let's say you're moving in a circular path. The time required to complete one circle is time period. Let's say you're doing an oscillation. Okay? So the time required to complete one oscillation is called as time period. Let's assume that you're talking about a wave. A wave looks like this, let's say. Let's say a wave looks like this. So the time required to complete one wave is called as time period. When the time period is fixed, we also understand that my frequency is also fixed. My frequency too does not change. My time period does not change. My frequency does not change. That is what looks like a harmonic motion. It is also observed that a harmonic motion always is expressed as sine theta, cos theta, or tan theta. Its general expression is sine theta, cos theta, tan theta. We may use other expressions as well. Like for a case, if I talk about sine theta, the sine wave looks like this. What is the story about the sine wave? If I use it as a function of time and displacement, I'll talk that this function of time it can be expressed as sine omega t. Omega has to be my constant angular speed, t happens to be my time, and this happens to be my sine function. If I assume that the amplitude of this is 1, as of now we know that sine theta has limits. Maximum value of sine theta can be 1 and minimum value of sine theta can be minus 1. So this happens to be a periodic motion, and since it is sine theta, it always repeats itself. It is also called as harmonic motion. If I was to draw about cos theta, the graph would look like this. This happens to be plus 1, this happens to be minus 1. Again, the function of time for this graph is cos of omega t. This is a periodic motion and it is repeating itself after regular intervals of time. Moreover, it is fixed. The frequency and the angular speed is fixed. The time period is fixed. When all these parameters are fixed, we call it as harmonic motion. If it is not a harmonic motion, not a harmonic motion means it may not be periodic, it may not be oscillatory, it cannot, even if it is a sine function, this may look like this. This is not a harmonic motion. This is just random sine function, very heavily disturbed. If I talk about a cosine function, a general cosine function is what this looks like, right? I'll create some disturbances. Let's say I just create these disturbances. It is no more a harmonic function. It is a non-harmonic function. So now you know what harmonic motion means and what non-harmonic motion means. A harmonic motion is a simple sort of motion where everything is periodic and oscillatory. Non-harmonic motion is a disturbed harmonic motion where things are not with the same time period, not with the same angular speed, not with the same frequency. So I suppose you have understood the difference between harmonic and non-harmonic motion. In a chapter henceforth, will be majority piece of this will be discussing about harmonic motion only. Only certain parts, if possible, will talk about non-harmonic motion, but our major focus will be on harmonic motion. So I want to see you people in our next video where we'll be discussing about SHM a lot. So until then, stay tuned with Study Life and keep learning with me. Thank you.